Sorry, go ahead, Desiree. Hit that again. So this objective we've been doing for a few days now, right? Just using our logic and our understanding to figure out what's left over, what the solution to a system might be. Corel, can you read the second objective for us?
I can say algebraic system equations to context systems.
Say it again?
Contextual.
Contextual. So, you know how Mr. Lewis and I keep telling you to not use an algebraic representation, to not create an equation? You're going to get to finally do that today, and we're going to make connections between what you've done in the past, logically, and with the equation. This will make your job much easier. However, too often teachers just jump right into the equations, and then it doesn't make a ton of sense for students. So we want to connect those ideas. You will want a separate sheet of paper today to show your work for each of these problems, and then show your connection. Does anyone need a piece of paper from up here?
No.
I'm not giving you one, Shelby. You literally stole a whole bunch of paper at the beginning. You have paper on your desk.
I was going to doodle on this one.
No, it's time to learn math.
There you go, Leo.
But like you already took paper. Like why would I give you more after you already took some? Oh, you didn't want to get out your notebook? It must be really tough. Okay, Layla, can you read our last objective for us?
I can solve the system equation by the elimination method.
So you remember how we keep talking about how, hey, these things eliminate each other, they cancel each other out, right? We're going to see a little bit more clearly why that's called elimination today when we look at these problems. Now, I was a scrub and didn't put number 1 in here, and that's my fault. But most of us have made it through number 2 already, correct? And a lot of us have even made it through number 3. Is that correct?
No, 3, 2, yeah.
I was saying, number 4 is where we start to get into a little bit more difficulty. But here's what I want us to do really quickly. Number 1, let's look at this. Does anyone have an idea of an equation you could create for number 1 based on the information there?
Yes, give me a second. Okay, so you can make a system of equations actually.
I'm just asking for one equation based on number 1.
Okay. 3x plus 4y is equal to 3x plus 4y is equal to 3x plus 6y.
Is equal to what?
Or is equal to 43.
There we go, right?
Whoops, I was doing something
Because
different.
it was equal to $43, right?
Yeah.
What were the things they were buying? Figaro flakes and Tabitha tidbits?
Tabitha first and then Figaro.
Okay, so 3 bags of Tabitha tidbits,
Yeah.
2 bags or 4 bags of Figaro flakes added up to a total of $43.
Mm-hmm.
That
Yeah.
represents what we see there, isn't it?
You might want to label those.
So X, so price of 1 bag
Tabitha
of
tidbits.
Tabitha tidbits, that's a good call. That's the dollars or price of 1 bag.
Because I noticed that this get me tripped up a lot because I keep having to go back to which one.
Yeah, so I will say, is there a way that we could have written it so it was more clear that it was Tabitha tidbits and Figaro flakes?
I mean, sure.
Yeah.
You could have done T and F.
Yeah. So I will point this out. If you're going to graph it, you have to write it this way. But if you're just doing it by elimination or substitution, you can write it this way.
I actually made a system in mine. I did that and then under.
Well, let's let someone else give us the other equation.
Mhm.
Layla, do you have any idea what the other equation might be?
3x plus 6y equals 54.
Okay, does anyone see anything wrong about this system right now?
I mean, we could cancel out the.
We're going to do that in a second. We're missing one thing.
Brackets,
Which type of brackets? Curly brackets, right?
The mathematical system brackets.
Okay, so remember, to make it a system, we have to group it together, right? Now, Peyton, what were you saying though?
I was gonna say now you can start the cancellation process. So 4
Now-
and 6 doesn't work.
But when we say the cancellation process, when we looked at this before, what did we always look for? We wanted something that was the same. And then we kept calling it a difference, meaning we were doing what with it?
Subtracting.
Subtracting. Now, a lot of times y'all kind of did the inverse of here, but I want you to think about it. Can I subtract all of this?
No.
Well, tell me this. What's 3x minus 3x?
I mean, yeah, but I thought you meant just that equation.
Well, but I'm subtracting this equation from the one above it.
Then yes, you can.
What's 3x minus 3x?
0.
Okay, so that eliminates the x, doesn't it?
Mm-hmm.
What's 4y minus 6y?
Negative 2y. But
Negative 2y. Which we kept talking about 2 bags of Figaro flakes. This is a little weird. Let's see how it plays out. 43 minus 54. Negative 11. And what's the relationship between negative 2y and negative 11?
both negative.
They're equal. We want to recognize that they're equal to each other.
So you divide.
Because didn't y'all divide at this point? What should we divide by? So one bag of Figaro flakes cost how much money? $5.50. Does that give us the same answer?
Yes.
And I like that Peyton said, hey, we need to define that variable, but notice we're literally just eliminating or subtracting if they have the same value or the same coefficient.
The only reason I said define the variables because I kept getting on 1, 2, and 3. I kept getting tripped. Wait, what is this? Oh,
Right.
wait, hold on. Wait.
Notice there's a level of beauty with having it as variables though, because now what is that 550 going to take the place of in one of those equations?
A variable.
Which one though?
That would take place of the
What is it equal to?
y,
Y.
which is Figaro flakes.
And so I want us to notice this is a big reason why we had you doing it without the equation at first. We needed to recognize, hey, I need something to be the same so that when I subtract them, it eliminates creating that zero. But this can be a little bit of an efficient method to working it out from there. And now I have an equation where I just need to solve for x.
I was taking an understanding check tomorrow, so.
Does that look familiar? That three of the Tabitha tidbits cost $21. And then we split that up into 3 to find out that one bag was equal to $7. So does that work agree with what we did logically? Okay? So here's what I want you to do to make sure that we pair these ideas well in our minds is every single one of numbers 1 through 5, we're going to work out logically first, and then we're going to write an equation, a system of equations like this to then work it out. That's why you have that separate sheet of paper. Does that make sense? Yeah, for that system of equations that we already just did. What I'm saying is work it out logically on 5.8 and then show the system of equations on that blank sheet of paper that you're going to put with it.
Hey, would you hate me if I kind of already did the system of equations on 5.8?
Not a lot, but you haven't quite done the system.
Nice.
So, here's what I want you to do. Starting with number 2, because most of us already worked that out, create the system for number 2 and then solve it using the equations, just like you did logically before. Once you do number 2, work out number 3 logically and then create the system for that. And keep working that way until I tell you what your homework is. Sound good? Good job. Thanks.